There's a bullseye in the Sahara Desert so massive and so perfect that astronauts use it as a landmark from space. It's 25 miles wide, and for decades, scientists thought it was an asteroid impact crater. They were wrong. The Rick-Hat structure, known as the Eye of the Sahara, is a geological formation so striking that it wasn't fully recognized until the era of satellite imagery. From the ground, you might notice the terrain rises slightly, that rocks form concentric ridges, but you'd never grasp the full circular pattern. From orbit, it's unmistakable, a perfect target in the middle of the desert. The structure consists of multiple concentric rings of rock layers, each ring made of different types of stone. Hard layers resist erosion and form ridges. Soft layers erode away, creating valleys between the ridges. The result is a series of nested circles stretching 25 miles across. The initial theory was impact crater, something that massive, and that circular must have been created by a meteor strike, right? But there's no evidence. No shock metamorphosed rock. No melted minerals. No raised rim of ejected material. The rocks aren't deformed in ways consistent with impact. The current scientific consensus is that the Eye of the Sahara is a deeply eroded geological dome. About 100 million years ago, molten rock, magma, pushed upward from below but never broke through the surface. It lifted the overlying rock layers into a dome shape, like pushing up the center of a blanket. Then, over millions of years, erosion removed the top of the dome and carved into the tilted layers, revealing the concentric ring pattern we see today. Different rock types erode at different rates. Sandstone, limestone, volcanic rock. Each responds differently to wind and the occasional rain, which is why the rings are so pronounced. The Eye sits in one of the most remote regions of Mauritania, far from major settlements, in a landscape that receives almost no rain. For local nomads, it's simply a landmark for navigation. But from space, it's iconic, a perfect circle of erosion, millions of years in the making, visible from hundreds of miles up, a reminder that Earth's geology can create patterns as striking as any impact from space.